Hi everyone, it's Sorkin. Today we have a problem when we are given a gas station. So for example, let's say that the gas station A, B, C, D, and E, and each gas station let's say that we have unlimited gas tank, and at each station we can take this is the how much gas we can take in that gas station, and the cost is that how much gas we should spend in order to go to the next gas station. So for example, let's say that at the gas station we can take gas amount of 1 and we need to spend the amount of 3 to go to the gas station B. And let's say the same with the gas station B, we can take 2 amount of gas and we need to spend 4 in order to go to the C and so on. So what we need to find is that can we complete a circle starting from any of these gas stations, let's say starting from A, B, C, D, can we complete a circle and go back to this where we have started. So let's say if we start from A, so can we complete a circle and go back to the A? And by requirement we need to find the starting position, right? Starting station. And by requirement we have, if the solution exists, then in that case we have only one start station. So how we're going to solve this problem? The first thing that we are going to do, the first thing is that we are going to calculate how much total gas we can take. Again, we have unlimited gas tank, right? So how much gas we can take, and we are going to calculate also how much total cost, which means that how much total gas we should spend going from one station to another station. So if the difference is less than 0, so it doesn't matter, so for where we start, we cannot finish the circle, right? Because in total we have less gas than the gas that we need to spend in order to make a circle. So that's the first one. If that is more than 0, so which means that yes, the solution exists and we need to find it. The way we are going to do that, we are going to maintain a current gas variable, and at each step we are going to check that can it be a starting position. So for example, in this case, can A be a starting position? No, it cannot be a starting position because we are taking only one amount of gas and we need to spend 3 in order to go to B. So we cannot start from the A. So how about B? Can B be the starting position? No, again, it cannot be. We are taking 2 and we need to spend 4. The same C cannot be the starting position because we are taking 3 and we need to spend 5. How about D? Can D be the starting position? Yes, it can, because we are taking 4, right? And to go to the next station, we are going to spend only one amount. So we are going to the next station, and if we start from the D, so we can complete our circle. So that's exactly what we're going to do. So if we are initializing 3 variables: total gas, current gas, and the start station. So at each step, so what we do is we are taking the difference between gas and the cost, right? So we are adding that to our total amount, and if we are also maintaining a variable current gas, which is equals to our to which we are adding our current. At each step we are checking that if at any point current gas is less than 0, then in that case it cannot be our starting position. So we are taking our starting position I+1, which means that the next gas station we are choosing our starting position, because until now, or whatever choices we have made, right? So if our current gas drops below 0, then in that case it means that the initial starting position that we have selected, it cannot be a starting position, because at some point it goes below 0. So which means that that initial starting point that we have selected, that cannot be our starting position. Then we are choosing a new starting position, and we are setting our current gas to 0 because we are going to start over. At the end, we are checking that if our total gas is more than 0, then in that case we are returning our start station. If not, then which means that the total gas is less than, so we cannot, doesn't matter where we start, we are going to return -1. So why the solution works? Let's take one more example. Let's say that our example in this case would be that we have again A, B, C, D, E, and in one gas station we have, in the last gas station, right, we have 16, and all other gas stations we have we have 0, so we cannot take any gas from here. Well, in that case, this will be our starting position. E will be our starting position, and the total amount is less than the total amount that we spent, the cost amount, right, is less than the total amount for the gas, which means that we can complete a circle. If we can complete a circle, then it means that we have a starting position. In this case, this is our starting position. So the last position, we are taking a gas and we can complete a circle. So what's the time complexity of this solution? Time complexity is of 1 because we are going over our array only once, and the space complexity is of 1 because we are not using an extra space. Okay, I also have identical solution in Java. I will include that in the description. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.